All right. We are into chapter 12 where we will be performing hypothesis tests. Okay. And we're doing a test about a population mean. There's sometimes a z-test for means or sometimes a t-test for means. And the deciding factor is really rooted in this. Do you know the population standard deviation or not? Okay. If you do know the population standard deviation, then we can use this to measure how many standard deviations of the sampling distribution we are away. Otherwise, you're stuck using this t distribution that we are hopefully familiar with, the student t tables, and it's based on the standard deviation of my sample divided by the square root of n. Because of that extra variability, we use a t table instead of a z table. Okay. So you need to know the difference between those two, and it depends on whether or not you're given the standard deviation of the population, sigma. But it's always your sample mean minus the claimed mean divided by either the standard deviation of population divided by square root of n or standard deviation of your sample divided by square root of n. But then from there, we can get a t-score and calculate a probability of either being greater than some claim, less than a claim, or not equal to a claim. All right. So if your t-value is 1.97 for a sample size of n equals 30, what would your p-value be? Okay. So we'll look it up on a t-table in a second, but it depends on the alternative hypothesis. If the alternative is that mu is greater than whatever claim, then you want the probability that you get a t-score greater than 1.97. If the alternative hypothesis is that mu is less than your claim, then the p-value is the probability that mu is less than your 1.97. Okay. If it is a not equal to, I couldn't get it to shade the outside parts, but it would really be these two probabilities added together. It would be 1 minus this shaded region in the middle, which ends up being double this because it's this on the right and then the mirror image that on the left. So it's the probability that you are below negative 1.97 plus the probability that you are greater than 1.97. So getting p-values really depends on which shape distribution you're dealing with. Okay. When you need to look at and this your calculator will give you, it's amazing. Your calculator gives you these probabilities depending on how you set up your alternative. If you want to use a t-table, it's a little bit messier. Okay. If it's one tail, either right or left, you use the tail probability. If it's two tail, a 5%, you just pick 5% outside is the same as 95% inside. If it's a 1% alpha two tail, you would use this. But basically, what you can determine is get what p-value it's between. Okay, so like if I got at a sample size of 30, degrees of freedom would be 29, and I got 1.92. I know that my p-value is, I need to be in this row somewhere. My 1.92 is somewhere between here and here. And so my alpha is somewhere between 10% and 5% at the two-tailed test. Okay, on two-tailed it's between 10 and 5. On the one-tail, it's somewhere between 0.05 and 0.025. Okay, so basically, I know that my p-value is somewhere, well, I know my t-score is somewhere in between these two values. Okay, and so if it's two-tailed, then I know that my p-value is somewhere between 10% and, or 0.10 and 0.05. But if it's one tail, then I know that my p-value is somewhere in between, in the same column, my p-value is somewhere in between these two numbers. Okay, so it's got to be a little bit bigger than that and a little bit smaller than that. And you can sort of see it's closer. 1.97 is closer to this. So we're going to be closer to 0.025 than we are to 0.05. But all you can do is land your p-value in between two columns. We don't get exact p-values from your t-table, but your calculator does give them to you. Okay, so good luck, and we'll get to this soon.